to present a brief overview of the Radler architecture definition language and its use within the ARCOS DesCert project. This project involved a tight collaboration between researchers at SRI Honeywell and the University of Washington. The broad goal of the DesCert project is to streamline and automate the certification process by supporting assurance-driven software design. The design process targets an efficient argument, one whose flaws would easily be identified by a skeptic. This efficient argument is supported by rigorous composable evidence that is generated continuously throughout the design lifecycle. Any design must meet its objective by deciding what stays fixed and what is allowed to change and how it is allowed to change. The fixed part, the statics, is the scaffold for the semantics, and the dynamics supports the functionality of the system. You can think of any designed artifact, a bottle, a vending machine, a building, or a plane, in terms of the statics and the semantics derived from it, and the dynamics and the behavior that it entails. An argument decomposes or refines claims into subclaims and assumptions. The claims are supported by subarguments, and the assumptions must be supported by evidence. The decomposition step itself should be supported by a theory with its own evidence. The point of the argument is to aid the skeptic in locating the flaws in the argument or the design or the theory itself. An efficient argument is one that would be easily defeated by a skeptic were it wrong. Good designs achieve efficiency by using useful abstract models, precise notations, trustworthy tools, and architectures that yield strong separation of concerns. These are all glued together by a shared ontology. In designing for efficiency for the skeptic and for zero-cost certification, we adopt a number of concrete steps: workflows with no evidentiary gaps, property-focused assurance, an associated evidence ontology, architectures based on a rigorous model of computation with logical and physical separation, component contracts, component models, static analysis for on-tick consistency, and automatic code generation from high-level specifications. In DesCert, a number of tools are used to meet these requirements for an efficient argument-based design. The architecture itself was designed using the Radler architecture definition language. Radler is based on a publish-subscribe paradigm for distributed systems, where the nodes execute quasi-periodically and communicate, i.e. publish and subscribe, on bounded latency channels with mailboxes that have bounded buffers. Radler architectures have a logical architecture as well as a physical architecture that assigns nodes to individual machines or virtual machines. Each node periodically executes a step function on the values in its subscription mailboxes to produce and publish output values. The Radler model supports an efficient argument by offering strong guarantees, some of which have been proved in PBS, at the architectural level for message ordering, bounded or zero message loss, latency bounds, failure detection and alarms, absence of deadlocks, absence of denial of service attacks, absence of infiltration or exfiltration. It breaks down behavioral properties, that's properties over time, into pre-post conditions and code contracts. It allows these components to be developed and tested independently and composed together into the larger system. Radler also has a build process in which executables are generated in order to ensure the architectural integrity of these executables. Radler was developed within HACMS at Dr. Kathleen Fisher's InSystems. The difference it made was dramatic. System build times went from weeks to a button push, since now the contributors knew their lanes. The overall DesCert automated certification workflow, integrating the tooling developed in phases 1 and 2, is shown in the picture. It starts with a workflow specification, and the ontology specification and the requirements to invoke a suite of tools for constructing various forms of evidence for the validation and refinement of requirements, the creation of test cases, and the production of executable code. An ingestion package for the RAC evidence knowledge base is automatically generated and invoked as part of the workflow. The end-to-end workflow fills out the evidence artifacts spelled out by the ontology, ingests the metadata generates the evidence using the tools, the tool wrappers that integrate them into ETB, generates the RAC metadata to support the construction and maintenance of the assurance case by the assurance case developers. In this way, the DesCert methodology defines and automates an end-to-end assurance-driven design methodology for continuous, rigorous, and composable assurance.